The 1930s airline industry was a knife fight. Every carrier desperately scrambled for passengers, battling outdated wooden aircraft and unreliable engines. Then Boeing dropped a bomb on the competition. In February 1933, they unveiled the Model 247, an all-metal twin-engine marvel with retractable landing gear that cruised at 188 miles per hour. But here's the catch. Boeing built all 60 aircraft exclusively for United Airlines, their own subsidiary. Transcontinental and Western Air, TWA, was locked out completely. While United passengers soared in comfort and speed, TWA limped along with aging Fokker trimotors. The balance of power was about to change. But first, TWA needed someone willing to build them something even better. That someone was Donald Douglas. What happened next created the most legendary aircraft in aviation history. TWA's problems went far deeper than just falling behind United. On March 31, 1931, TWA Flight 5 crashed in Kansas, killing all 8 people aboard, including Notre Dame's legendary football coach Knute Rockne. The investigation revealed a terrifying flaw. Moisture had seeped into the wooden wing laminations of the Fokker F-10, causing the glue to fail and the wing to collapse mid-flight. The U.S. Department of Commerce responded swiftly, imposing strict restrictions on wooden wing passenger aircraft. Much of TWA's fleet was effectively grounded overnight. The airline faced an existential crisis: compete with outdated technology or find a way to leapfrog the competition entirely. Jack Fry, TWA's ambitious president, chose the latter. On August 2, 1932, he sent detailed specifications to 5 aircraft manufacturers. His requirements were brutally demanding: an all-metal trimotor carrying 12 passengers across 1,080 miles at 150 miles per hour. But the real challenge? The aircraft had to climb on a single engine from any airport on TWA's system, including high-altitude locations like Albuquerque. In an era when engines failed constantly, this wasn't just a safety feature, it was survival. Donald Douglas initially wanted nothing to do with the project. He calculated that his company would need to sell at least 100 aircraft just to recover development costs, a nearly impossible number during the Depression. But his chief engineer, Arthur Raymond, saw something Fry's competitors missed. During a critical phone conversation with Douglas, Raymond ran rapid calculations and realized they didn't need to build what TWA asked for. They could build something better. Instead of a trimotor, Douglas proposed a twin-engine design that would exceed every single specification Fry had outlined. The key to making this work? A technology called the variable pitch propeller, what Douglas himself would later call perhaps the most important innovation of the decade. This allowed pilots to adjust blade angles for different flight conditions, meaning a twin-engine aircraft could now meet climb requirements that previously demanded 3 engines. Raymond also incorporated Jack Northrop's stressed skin wing construction, a technique that distributed aerodynamic loads across the entire metal skin rather than concentrating them in traditional spars. Lighter, stronger, more efficient. When Raymond told Douglas he was 90% confident they could meet the single-engine climb requirement, Douglas considered that good enough. The project was green-lit. They called it the DC-1, Douglas Commercial No. 1. The DC-1's first flight nearly became its last. What happened in those 12 terrifying minutes would expose a fundamental installation error that could have killed everyone aboard. July 1, 1933. Test pilots Carl Cover and Fred Herman climbed into the DC-1 at Cloverfield in Santa Monica. The plan was simple: a brief evaluation flight to test basic handling. They lifted off at 12:36 p.m. Within minutes, both Wright Cyclone engines began cutting out repeatedly during the climb. Power surged, then died. Surged again, died again. Cover and Herman coaxed the crippled aircraft through a 12-minute flight that tested every bit of their skill. They managed to land safely, but the cause of the engine failures baffled everyone. The answer, when discovered, was almost embarrassing. The carburetors had been installed backwards. During nose-up climbs, the float mechanisms closed instead of opening, starving the engines of fuel. This wasn't just a simple mistake. It revealed how experimental aircraft development really was in the 1930s. Even fundamental installation errors could slip through inspection. The carburetors were corrected. On September 4, 1933, the DC-1 successfully demonstrated single-engine takeoff from Winslow, Arizona's high-altitude airport, exactly what Fry had demanded. TWA accepted delivery on September 15th. The only DC-1 ever built was ready to prove itself. But the DC-1 was just a stepping stone. What came next would prove that sometimes the prototype is just the beginning of something far greater. While TWA evaluated the DC-1, a political crisis was about to hand Douglas the perfect marketing opportunity. The 1934 airmail scandal erupted when President Franklin Roosevelt cancelled all commercial airmail contracts on February 19th, assigning delivery duties to the U.S. Army Air Corps instead. The military operation turned catastrophic. Within 3 months, the Army experienced 66 major accidents and 13 crew deaths. The problem was obvious. The Army relied on obsolete open-cockpit aircraft, completely unsuitable for commercial mail routes. Jack Fry and Eddie Rickenbacker from Eastern Airlines saw their chance. On February 18th, they flew the DC-1 from Burbank to Newark in 13 hours and 4 minutes, a new transcontinental record. The timing was perfect. While Army pilots struggled with outdated equipment, the DC-1 showcased the fundamental superiority of modern commercial aircraft. By May 8, 1934, airmail service was restored to commercial carriers. The demonstration worked. TWA immediately requested modifications for production. 14 seats instead of 12, requiring a longer fuselage and increased wingspan. Douglas called this variant the DC-2. The first aircraft was delivered on May 22, 1934, at approximately $80,000 each. Between 1934 and 1939, Douglas built 198 DC-2s, 130 civilian and 62 military versions. But the real transformation was still ahead. C.R. Smith, the 35-year-old president of American Airlines, had a vision that would create the first airliner capable of making money from passengers alone. No government subsidies required. Smith approached Douglas in 1934 with an audacious request. Combine the DC-2's speed and reliability with the passenger comfort of sleeper trains. He wanted upper and lower berths, a flying hotel. During what became known as a marathon phone call, Smith outlined specifications that would require complete airframe redesign, not just DC-2 modifications. American Airlines committed to ordering 10 Douglas Sleeper Transports, DSTs, plus additional 21-seat day configuration variants. Smith even secured a $4.5 million loan from the Reconstruction Finance Corporation to back the order. Raymond's engineering team initially estimated only 15% new parts compared to the DC-2. They were wrong. When the design was finalized, only 10% of components carried over. The DC-3 was essentially a new aircraft. The DST made its first flight on December 17, 1935, the 32nd anniversary of the Wright brothers' first flight, with Carl Cover and his crew aboard for a 100-minute evaluation. Service began on June 25, 1936 on American's flagship Chicago to Newark route. The fare? $47.19 for a 4-hour journey. At $110,000 per aircraft for American Airlines, the DC-3 was expensive. But it delivered something no airliner had achieved before: profit from passenger revenue alone, without relying on government mail contracts. C.R. Smith famously declared the DC-3 the first airplane in the world that could make money just by hauling passengers. The numbers proved him right. By 1939, DC-2s and DC-3s carried 90% of all U.S. airline passengers. By December 1941, Douglas had delivered 507 DC-3s, with 434 going directly to airlines. Commercial aviation had been transformed. Airlines could now expand routes based on passenger demand rather than chasing government contracts. When World War II erupted, the DC-3 became the C-47 Skytrain, one of the war's most critical weapon systems. The US Army Air Forces called it the C-47, the Navy designated it the R-4D, and the British RAF knew it as the Dakota. Douglas established production facilities in Long Beach, Santa Monica, and Oklahoma City. The Oklahoma plant alone produced 5,354 C-47s between March 1943 and August 1945. Total U.S. production reached 10,174 military aircraft and 607 civilian DC-3s. Over 10,600 aircraft built between 1934 and 1945. Douglas employment peaked at 160,000 workers. Women comprised 40 to 65% of the workforce, fundamentally transforming both aviation manufacturing and American society. But production went global. The Soviet Union, after engineer Boris Lisunov spent 2 years at Douglas facilities acquiring licenses, built 4,937 Li-2s through 1954. Japan manufactured 487 L-2D variants, designated Tabby by Allied forces. Combined global production exceeded 16,000 DC-3 family aircraft across 4 nations: American, Soviet, and Japanese factories, all building variations of Arthur Raymond's design. The DC-3's impact extended far beyond the numbers. It established Southern California as the global aerospace manufacturing center, created the customer-driven aircraft design philosophy that persists today, and proved that systematic engineering collaboration between airlines and manufacturers could produce world-changing results. As for the original DC-1, after its testing duties ended, it was sold to Howard Hughes, then eventually ended up in Spain, where it was destroyed during the Spanish Civil War. Only one was ever built, but it served its purpose, proving that Douglas could build something extraordinary. The DC-3 continued flying commercially for over 85 years after its first flight. Over 400 remained in service as late as the 1990s, a testament to Raymond's engineering and Douglas's vision. But the real legacy isn't just the aircraft. It's the process: systematic testing, collaborative design, customer engagement, iterative refinement. These methodologies established the foundation upon which the modern aerospace industry was built. The DC-3 didn't just change aviation in the 1930s. It created the blueprint for how we've designed aircraft ever since.